Let us now look at the molar concentration. So concentration is the number of moles of solute present in 1 cubic decimeter of a solution. In this case, the units of concentration can be written in this form as mole per cubic decimeters. So according to that definition that I have said, the units for concentration, they're going to be given in this form as mole per cubic decimeters there, and this can be written in this form. So we have mole per cubic decimeters, and mole per cubic decimeters can also be referred to as molar. So we have molar there as represented as capital letter M. So concentration can also be defined as the mass of solute present in 1 cubic decimeters of a solution. So according to that definition, the units in this case is grams per mole. So according to that definition, the units are going to be in grams per cubic decimeters, and this can be represented as grams per cubic decimeters. So that means that concentration can be represented by mole per cubic decimeters or grams per cubic decimeters. So there are two formulas that can be used to calculate the concentration of a solution. These formulas are given below. So the first one that we're going to look at is C is equal to N divided by V. So we can say where our C there represent the concentration of the solution. So we have concentration of the solution there, which is given as mole per cubic decimeters. Then we can say N represents the amount of solute. So we can say N represents the amount of solute. So amount of solute, and that is represented by mole. Then V is the volume of the solution. So V is equal to volume of the solution. And the units there, we have cubic decimeters. Then the other way in which we can represent, we can calculate concentration there. We can say concentration is equal to M divided by V. And we can say where C represents concentration, and there the unit is going to be gram per cubic decimeters. Then M there is going to represent mass of solute. So we have mass of solute, and that is in grams. Then V is going to represent volume of the solution. And the unit is cubic decimeters. Let us now look at our examples. We have the first example there. A solution of sodium iodine in water contains 3 grams of solute in 100 cubic centimeters of solution. Calculate its concentration in a gram per cubic decimeters. So the first thing there that we're going to do is to collect our data. So we're going to collect our data there. So the mass there we have been given as 3 grams. Then the volume we have been given as 100 cubic centimeters. So we need to convert 100 cubic centimeters into decimeters, and converting that into decimeters, cubic decimeters, we're going to divide by 1000, and our answer there we're going to have 0.1 cubic decimeters. So there we're going to have 0.1 cubic decimeters. Then the concentration, we don't know. We're supposed to calculate concentration there. So we're going to say concentration is equal to mass divided by volume. So concentration is equals to mass there is 3 divided by volume is 0.1. So concentration is going to be equal to 30 gram per mole. So that's going to be our answer. So B, we have mole per cubic decimeters. So the first thing that we're supposed to do is to collect the data. So mass, we know that we have been given as 3 grams. Then the other thing that we know is that our volume we have been given as, we had calculated volume as 0.1 cubic decimeters. So that's our volume. So 0.1 cubic decimeters. Then the molar mass, we're supposed to calculate the molar mass of sodium iodide. So we have sodium iodine there. The mass number of sodium, if you check on the periodic table, it's 23. Then the mass number of iodine there on the periodic table is 127. So to find our answer there, we are going to have 150. So that's going to be 150 gram per mole. So our molar mass there we're going to put as 150 gram per mole. And there we don't know the number of moles and we don't know the concentration. So the first thing that we're supposed to do is to calculate the number of moles, and you can say number of moles is equal to mass divided by the molar mass. Number of moles is equal to mass, we know that 3 grams divided by the molar mass we have calculated as 150. Number of moles is equal to 3 divided by 150, you're going to have 0.02 moles. Then since we know the number of moles there, we can say concentration is equal to number of moles divided by volume, and we have calculated as our number of moles as 0.02. So that's going to be divided by volume there, it's 0.1. So we have 0.1. So concentration is equal to 0.02 divided by 0.1. We're going to have 0.2 mole per cubic decimeters. So that's going to be our answer. Or we can say concentration is equal to 0.2 molar. Let us look at question 2. So we have question A there. How many moles are contained in 200 cubic centimeters of solution of 0.02 molar of sodium hydroxide? So how many moles are contained in 200 cubic centimeters of solution of 0.02 molar of sodium hydroxide? So the first thing there that we're supposed to do is to find our data. That's the first thing that we're going to do. So we're going to say data there. Then volume is equal to, we have been given 200 cubic centimeters, and converting it into decimeters, we're going to have 0.2 cubic decimeters. Then concentration is equal to, the concentration have been given as 0.02 molar. Then the number of moles we don't have there. So we can say that concentration is equal to number of moles divided by volume. And to make number of moles there as the subject of the formula, we are going to cross multiply, and we're going to say number of moles is equal to concentration multiplied by volume. So our number of moles is equal to concentration there, we have 0.02 molar multiplied by the volume we have 0.2. So number of moles is equal to 0.02 multiplied by 0.2, we're going to have 0.04 moles, and that's going to be our answer. So our answer is 0.04 moles. Then question B reads, calculate the mass of sodium hydroxide used. So make sure you find this one. Also question 3 reads 0.5 grams of aluminum chloride are dissolved in 2 liters of solvent. Calculate the concentration of solution in A gram per mole, then B mole per cubic decimeters. Also make sure you find this question and share your answers in the group. So that's all about concentration. Where you have questions, please ask in the group. I'll meet you next time.